Hey scholars, so we've learned so much about quadratics already. We've learned how to solve them, how to find the zeros, how to find the vertex, how to find the axis of symmetry. Today we want to tie it together and show you how to graph quadratics. If you ever have any questions, please send me emails. You all actually do a really good job of that. Make sure you're using your school email address when you complete your assignment so that you can accurately submit your IP. It's not too late to turn in late work, so please turn that in. You have until May 21st. Please don't guess, leave blanks, I don't know. You can email me or come to office hours. I have office hours every day from 10 to 11 a.m. If that doesn't work, we can schedule a private office hour. Make sure you have your pencil and paper out ready to take notes and try the problems as we go. The quarter ends May 22nd. If you're passing with a C or better, then you're done. If you are not, you will need to continue working for 2 more weeks. So let's get those assignments all handed in. The bonus project is due May 22nd at midnight. It's worth 20 points, which is basically the same as 2 e-learning assignments. The expectations and the rubric for this project can be found on my haiku page. Okay, so we talked about characteristics of a parabola last time, so I want to open up with that today. So the direction of this quadratic, if we look at the graph, it's a U shape. So this is an up direction, okay? So the x-intercepts are where the graph crosses the x-axis. So the first place where that happens is here, and this point is -1, 0. And the second place where the line crosses the x-axis is right here. And that point is 3, 0. So our 2 zeros are -1, 0 and 3, 0. Okay. The y-intercept is where the graph crosses the y-axis. So if we take a look, the only place where our graph crosses the y-axis is going to be right here. Okay. So our y value there is -3 and our x value is 0. So the way that we write our intercept is as a point, and it would be 0 for our x value and -3 for that y value. Okay, now let's find that line of symmetry. So where does our graph split in half? So if we look here, let's choose a bright color. Let's try green. It looks like our graph will symmetrically split in half just at this line here. Okay, and we need to figure out what that x value is where our parabola is split in half. So let's find that y value, or excuse me, that x value. That x value is actually x equals 1. Okay, so our line of symmetry is x equals 1. Okay, last thing that we can take away from our graph here is the vertex. Remember, the vertex is a point, and our line of symmetry is always the x value of our vertex. So our line of symmetry value is 1, therefore our x value of our vertex is 1. Our actual vertex is right down here at the minimum point of our graph, and that y value connects to -4. So our vertex is 1, -4. So looking at a graph of a parabola, in this case, we're looking at y equals x squared minus 2x minus 3. We can find the following information. We can find the direction of our graph, the x-intercepts, also known as the zeros. We can find the y-intercept, the line of symmetry, as well as the vertex. Lots of great information. Okay, so if we want to graph a parabola, we do have to find these 5 items in order to graph. Okay, so last time we made a rough sketch of y equals -2x squared minus 8x minus 6. We found that the zeros were -1, 0 and -3, 0, and we graphed those. Okay, so we were here and here with our zeros. And then our line of symmetry was at x equals -2, so that's where our graph split in half. And then our vertex was negative 2, 2, right up here at this maximum point. And then our direction of our parabola was down, okay? And we created this blue graph here that I'm going to draw an arrow to. So this, if you can see the blue parabola underneath the light pinkish color there, that is the graph that we drew, okay? It wasn't perfect, but if you look on top at this bright pinkish parabola, that one's more perfect, okay? And we can actually make our graphs just as perfect as this pinkish graph. All we have to do is find more points, okay? So let's walk through the steps of graphing a parabola from start to finish. So the first step here is underlined for us, and it says step 1 is standard form. So let's put our quadratic here in standard form. Well, we want to get y by itself, so we're going to subtract 3 to both sides. And on the left side, our 3's are going to cancel, so we have y equals x squared plus 4x minus 3. Okay. First step to graphing is to put that quadratic in standard form. Okay. Next thing we want to do is find the x-intercepts, or also known as the zeros. So there are two things that we can use to find the zeros. We can either find the zeros using the quadratic formula, or we can find the zeros by factoring. Okay. I always like to start by finding the zeros by factoring. And if it can't be factored, so if it's not factorable, then I like to go to quadratic formula. That's my preference. You can start with a quadratic formula if you like. The quadratic formula always works. Okay, so let's start by factoring. So our a value is 1, our b value is 4, and our c value is equal to negative 3. So we need to find two numbers that multiply to a times c, which is negative 3, and adds to 4. Okay, so if we think about those numbers, negative 3 and adds to 4. Well, in this case, we see that in fact it's not factorable. Okay, if we choose negative 3 and 1, that does give us negative 3, but it adds to negative 2. And even if I make my 1 negative, I get negative 3, but then it adds to 2. So in this case, we do indeed need to use the quadratic formula. Okay, so factoring didn't work. It's not factorable, so let's use the quadratic formula. So we'll have x equals negative b plus or minus the square root of b squared minus 4ac, whoops, I didn't mean to write those letters there, 4ac all over 2a. Let's fill this in. So b squared, excuse me, negative b, so 4, and then b squared minus 4 times a times c all over 2 times a. Let's go ahead and simplify. So we'll have negative 4 plus or minus the square root of 16 plus 12 all over 2. And this is negative 4 plus or minus the square root of 28 all over 2. So we have this square root of 28 that we need to simplify, and this is a great time for us to use our calculator. So on your calculator, you want to find the square root function, and you want to type the square root function and then 28, and then you want to press enter. When we do that, we get that the square root of 28 is equal to 5.3 if we round it to the nearest tenth. Okay, so we can actually substitute our square root of 28 with 5.3 here. Okay, so this plus or minus symbol tells me that I have to create two equations to find my zeros. So the first one is going to be with the plus sign. So -4 plus 5.3 divided by 2. That's going to give us one value of x. And then our second value of x is going to come from -4 minus 5.3 divided by 2. Okay, so we can calculate these separately, making some space here, and we'll find both of our x values. So for the first one, we have -4 minus 5.3 divided by 2, and that gives us 4.7 if we round it to the nearest tenth. And then we have -4 plus 5.3 divided by 2, and that gives us 0.7 if we round it to the nearest tenth. So we found our x-intercepts. Okay, let's go ahead and write our x-intercepts as points. Okay, that way when we want to graph it, we know exactly where to go. So for our first one, 4.7, we would actually write this one as 4.7 comma 0, and our second one would be 0.7 comma 0. Okay, now we have our x-intercepts or zeros as points, so when we're ready to graph them, they'll be ready to go. Okay, our third step is to find the vertex. So the vertex has to be a point with an x value and a y value. So to find the x value, we have to use a specific formula, and that specific formula is x equals -b over 2a. Okay, so remember a is 1, and we can use our standard form to find this out. B is 4, and c is -3. So x equals -4 divided by 2 times 1, and this simplifies to -4 over 2, which is equal to -2. So our x value for our vertex is -2, and that value is also our axis of symmetry. So that's where our graph is going to split in half. So we found the x value of our vertex. All that's left is to find the y value. So to find the y value, we substitute the x value back into our standard form and solve for y. So we'll have y is equal to x squared plus 4 times our x value minus 3. So we'll have our x value is -2, so we'll plug -2 in wherever there was an x. So this is now equal to -2 times 2, -2 squared is 4, plus 4 times -2 is -8. So I'm just going to make the negative override that plus sign, put an 8 there, and then -3. Order of operations tells us to simplify from left to right, so we'll have -4 minus 3, and this sums up to -7. So our y value for our vertex is -7. Okay, so this is what we know so far. One of our zeros is 0.70, like we calculated. Our next zero is -4.7, comma 0. Our line of symmetry is x equals -2. And our vertex is going to be -2, -7. Okay. Which direction, if we look at our graph, do you think our graph opens up at? Well, if our vertex is down here at the bottom, it's gonna open up like a cup. Okay, so we can kind of do an estimate of what our parabola would look like. Okay, but we're not going to stop here today. Okay, we want to get our graph to be more accurate. So there's actually one more step that we want to do. So before we want to graph this, we want to actually find more points. So we have to create a table of values and then we can graph. Okay, so let's use our zero, or let's graph our zeros very quickly. We already had them in the previous slide. So our 0 was 0.7 comma 0, and then we had negative 4.7 comma 0, and then our vertex was negative 2, negative 7. So let's put all three of these points on our graph first. So negative 2, negative 7 is our vertex down here at the bottom. 0.70 is an approximate. I'll put that about right here. And then negative 4.70 is going to be somewhere between 4 and 5. Okay. All right. Let's add more points to our graph. So I'm going to always put our vertex point in the middle, and that's our basis for our table. And I want to choose a value that comes before negative 2, which is negative 1, and then after negative 2, which is negative 3. So we need to find the x value, the y value that corresponds with the x value negative 1 and negative 3. So what we have to do is plug those values back into our original quadratic here. So we'll do the first one. So we'll have y equals negative 1 squared plus 4 times negative 1 minus 3. And this simplifies to 1 minus 4 minus 3, which is equal to negative 3 minus 3, which is equal to negative 6. So the y value that corresponds to x equal negative 1 is negative 6. And then if we want to find the y value that goes with negative 3, let's plug that in. So we'll have negative 3 squared plus 4 times negative 3 minus 3. And this is 9 minus 12 minus 3. And this is equal to negative 3 minus 3, which equals negative 6. Okay. So what you should notice is that those y values are the same. Negative 6 and negative 6 on either side of our vertex here in the middle. Okay, which is usually what will happen. So let's go ahead and graph the point negative 1, negative 6. We already graphed our vertex negative 2, 7, negative 7. So we don't need to do that. And then we need to graph negative 3, negative 6. So negative 1, negative 6 is about her. And negative 3, negative 6 is about right here. Okay, so we have more points to make our graph slightly more accurate. And let's connect these, and Miss Lockhart is going to take her time so she can try to make it somewhat beautiful. Almost. I want to be a perfectionist and erase that and try one more time. I want to get through that 0. Oh, that's fine. Got close. Okay. And then we have a 0 here. Cool. So this is our quadratic graph. Okay, you can try. First step is to put it in standard form. Then you want to find your A, B, and C value. Then you want to find your zeros. Remember, you can either factor or use the quadratic formula. Then find your vertex, which means you have to find the x value using negative b over 2a, and then plug in that x value into the original equation to find the y. Go ahead and give it a try. Okay, so we add 5 to both sides first. So our standard form is going to be y equals, well, this cancels, negative x squared plus 4x plus 5. So our a value is negative 1, our b value is 4, and our c value is 5. So let's see if this is factorable before we use the quadratic formula. So two numbers that multiply to a times c, which is negative 5, and adds to 4. Yes, we have something that works. We can use 5 and negative 1. So let's go ahead and plug that back into our original equation. So instead of writing 4x, this time we're going to write our magic numbers in. So negative x squared plus 5x minus 1x plus 5. Now we want to factor by grouping. So we'll group the first two and the second two. We'll have to squeeze a plus sign in between. I can take out a negative x, and I'll have a x minus 5 left. And I can take out a negative 1 from here, and I'll have a x minus 5 left. So my first factor is x minus 5. If I go ahead and scratch out my x minus 5 and write what's left, I have the remains for my second factor. So it'll be negative x minus 1. Okay. And the last step is to find the zeros, and that means we're gonna set both of our factors equal to 0. So we'll have x minus 5 equals 0, and negative x minus 1 equals 0. So this 0, we'll have x equals 5. And for this 0, we have to do 2 steps. So we'll add 1 to both sides. We'll get that negative x equals 1. Then we have to divide by negative 1. So our other 0 is going to be x equals negative 1. So here are our 2 zeros. Okay. Remember, if we want to write these as points, we'll have negative 1 comma 0, and then we'll have 5 comma 0. Okay, so we have our zeros. Now let's find our vertex. So let's plug in our b and a value here. So negative b would be negative 4 over 2 times negative 1, which is negative 4 divided by negative 2. So x is equal to 2. So we're going to plug this x equals 2 into our original standard form to get our y value. So wherever there's an x, I'm going to place a 2 there. So negative 2 squared plus 4 times 2 plus 5. So this is equal to negative 4 plus 8 plus 5, and this is equal to 9. So our vertex is 2 comma 9. All right, so I went ahead and made most of the table for you. So I graphed the zeros and the vertex and the 0. So our first 0 was negative 1, 0, which you can see in green on the graph. And then 2, 9 is at the very top. That's our maximum. And 5, 0 is the second green dot on the graph. And then I added 2 more points to our graph so that we can make it more accurate. So I added -2, 7 and 6, -7 to the graph, and it made it much more perfect. Okay, so great job. Guess what? Do you know about Desmos? So Desmos is this really cool online program where you can graph quadratics on the computer and you do not have to do it by hand. So literally you go to desmos.com, you click start graphing, and you can actually graph away. When you get there, you can type in any equation into this area right here and click enter, and it'll graph it for you. That's exactly how I got those perfect graphs that you saw throughout the presentation. So let's do some investigating. I want you to go to desmos.com, and I want you to start by graphing y equals x squared. Okay, and take a look at it. And then I want you to change x squared to -x squared. And I want you to tell me what happens if the coefficient on the x is negative. What happens to the direction of the graph? Okay. What happens if you add or subtract from x squared? So put x squared plus 1 in there and see what happens. And then put x squared minus 1 and see what happens. I wrote all these down on this side here. So you want to type in y equals x squared, y equals -x squared, y equals x squared plus 1, y equals x squared minus 1. One at a time, of course. Don't put all of them in at once. Just go through one at a time. Then you're going to do y equals x plus 1 squared. And then type in y equals x minus 1 squared. And then I want you to see what happens if the coefficient on the x is a fraction. Okay? And see what happens there. So just choose a couple of these to go ahead and type into desmos.com and see what happens with those graphs. Okay? Oops. All right. I want you to try this out as well. So on Desmos, I want you to graph a parabola that has zeros at -2, 0, and 3, 0. So you can just plot those points and see what comes up. And then I want you to graph a parabola. Actually, just make them have all 3 elements at once. So go ahead and graph on your Desmos. Graph a parabola that has zeros at -2, 0, 3, 0, has a vertex of 1, -3, and a parabola that opens down. See if you can figure that out. Great work today. You have choices for the type of IP that you want to complete. So you can go to Haiku and find the directions for the parabola in the wild assignment. Okay, so you can do this assignment, and if you do the parabola in the wild assignment, you do not have to complete the rest of the IP form. But if you don't want to do the parabola in the wild assignment, then you can complete the regular IP form and email me with questions, okay? Don't forget to begin working on your bonus project if you haven't already. Shout out to Hanaya for submitting hers yesterday. Fantastic. The code word for today is strong. I want us to finish out the semester strong, get in those missing assignments, and hang in there. You're almost done. Have a great day.